We are starting the demo video for Qpsk modulation and demodulation trainer kit. In this trainer kit, we have a single kit for modulation and demodulation, where we have this is our major data input. The major emphasis of the experiment will be on the qubits, which will be the MSB 0, D0 and D1. What I will be showing you in this experiment will be this output. For the qubit 0, D0, D1, 00, 01, 10 and 11, the modulation phase shift of the Qpsk of 0 degree, 180, 270 and 90. For context, before starting the video, I would like to show you the process of calculating the phase angle for the output of the modulation signal. On that, we have to first focus on the sine wave. Every fundamental sine wave is in this similar pattern with a crest and a trough. It starts from 0. If the cutoff is from starting is on this side, it is called the 90 degree. If it is from this side, it is called 180. From here, it is called 270. And here again, it will be called 0 or 360, which is one and the same thing. So, using this analogy, we will be continuing our video of Qpsk modulation and demodulation. For the Qpsk modulation demodulation, the first is the word itself. Qpsk is quadrature Psk. By quadrature, we mean to say that it is a four-way technique, that Psk in 4 data bits can be done simultaneously at once. So it is a 4 Psk kit. The actual thing what is happening is our signal data of a digital data is converted in modulation with using the phase shift as a modulation technique. For the actual process, which is also used in every modem outside right now, we are using a reference carrier, which will be a sine wave, which will be used as a reference point for considering the phase shift. This next is the 190 degree phase shift, 270 and 180 degree phase shift. In this case kit, we have our balance modulator, we have a modulation and demodulation section, we have our data generator. This 89S52 controller is used to generate data, and here on the LED you can see the data input and the output both. The color coding scheme is on the kit is somewhere so that it is easier for the user to understand the input and the output connections. So let us start making some connections for the experimental purpose. So the first connection will be data to modulation, and here it is data from demodulator, and this is our demodulator. So data to modulation will go to MSB. This is our modulation section. So orange, the I bit goes to the I bit, the Q bit goes to the Q bit. Next comes our modulation section, demodulation section, I to I, Q to Q. Then comes our selection of the conversion input clock, goes from this point to our conversion clock output. The final connection in this trainer kit will be our Qpsk input to the Qpsk output. Now this is the basic connection which you need to do. Now comes the connection for our, this is my Qpsk output DSO connection, this is my ground. Then comes the second probe which goes to the reference. Now what I have done is, on yellow we have the reference input and the blue will be our output. We'll set them both to 0. Now we'll keep our reference on the top. We'll first both 0, then reference on top. This is my output. As you know, due to RC component, there will be a phase shift, and there is also a method to overcome that, which I'll show you later in this video. Now first, let us consider the first scenario of the Q bits being 0 and 0, the phase shift is 0. The meaning of the phase shift 0 is that if you trace the input by a simple method of generating dots, let me show you. Even on a DSO, there's a very simple way: bottom, top, mid, mid, bottom, mid, and top. So now this is a complete sine wave. If you superimpose that on this, there is no change. So considering that this is our 0 0, there is no change, the input and output phase are same. Now what I'll do is we'll go for 0 and 1. For that I'll be using the pin of the 2 pin cable. You have to understand that D0 is our MSB. So do not fool by 1 to 8, because it is in a way that our 8 is D0 MSB and 1 is the LSB. I'll just pause it. Now I'll expand it. You have to understand the 0 1, the initiation of the wave. As you can see clearly here, the signal here is getting cut off at this point. The starting of the wave is exactly from the midpoint, which as per we have shown is, this is our 180. So the bottom swing and the crest and the trough. So this one is considered as the 180 degree phase shift. So let me show you in a closer way. So this is our 180 degree phase shift for our data 0 1. Now we will go for the next, that is 1 0. We will make 8 high and 0. We will again stop. Now what you will see is the waveform is starting from the bottom side. That is our 270. Our 1 0 is at the phase shift is at 270. Now comes the final qubit configuration of 1 1. You can see that the cutoff is from the top, that is the 90. This is the 90 waveform. So at 1 1 we have the 90 degree shift. So this is our Qpsk modulation. Now for the demodulation, this is actually the modulation part, and for the demodulator you can simply use this, and you can use a double wire on this point. And let us go for the second probe output. You can use one more double probe here and here and this. So this is my demodulator output. The demodulation is also in as per qubits. So it is the even bit and the odd bit. So at 8, this is my D0. This will be my D0 and this is my I bit. And this is my Q bit. So you can see the modulation and demodulation of the Q bit and the I bit on the DSO and on the LED itself. So this is the modulation and the demodulation of this limit bit.